Oh, hi, Jeff, with the Appliance Hospital. I wanted to make a quick video covering a head fake that technicians will run into in the field that can really put them down the wrong path when they're doing electrical troubleshooting. And to introduce what I'm talking about, I'd like to share a Zen koan that may expand our minds or may melt our faces. What does it mean to measure the voltage at a single point? So here's what I mean specifically. Right now, we're measuring 120 volts, open circuit, with no load, from an 120 volt outlet. I have my red probe in the line terminal, and I have my black probe in the neutral terminal. And the question I'm asking is, what is our meter going to display if I remove the probe from the neutral pin? Final chance. Make your guesses. Place your wagers. So that might be kind of surprising. You might think it should show 0 volts, 0.0. There is no voltage between this probe and that probe. But the fact is, we live in an analog world, and nothing is 0. This is ghost voltage, and a couple things to notice about it. As I touch the probe, even if I don't touch the conductor, as my hand gets closer to it, notice that the displayed voltage goes up, 5, 6 volts, almost 7. And if I do actually touch my probe, which is, in this case, electrically safe, now it shows 42, 44 volts. That's the definition of ghost voltage. This is showing ghost voltage, which means our meter is drawing so little power from the circuit, it has such a high input impedance, is the term of art, that it's showing voltage that doesn't actually have the capacity to do any work. And what that means in practice is usually that we have an open neutral, which is exactly what we're showing here. This black probe is actually acting as an antenna, and it's coupling with the environment to give a ground reference for our red probe. So anytime you see this condition where your meter is showing voltage that changes as you move or touch your probe, that should be a really good clue that you have an open neutral somewhere. And you'll need to find that to find the problem. So what did that tell us? Well, it told us a couple of things: that we had a break in the circuit, that it was somewhere upstream from us, and in my case, that was because I had disconnected my probe from the outlet. But we would see the same phenomenon if the wiring in the wall was disconnected from the outlet, or if the receptacle to wiring connection was okay, but there was a break between the wiring and the circuit breaker for that circuit. Those would all show up as ghost voltage, and they would all tell us that we had an open neutral, and that's what's key. Another easy way to know if you're seeing a ghost voltage or a real usable voltage, some higher quality multimeters will have what they call a low Z function. Z is the symbol they use for impedance, which is, for these purposes, almost the same thing as resistance. It's presenting more of a load, it's drawing more current from the outlet to bleed down that ghost voltage and tell us if there's actual usable voltage there or if it's just a measurement artifact. So if I clip over to low Z, you can see right now it's showing the same reading, 120 volts. 122 is 120 volts. If I disconnect the neutral lead, it shows 0. It tells us there is nothing usable there. And the only thing the meter has done is it's connected a resistor, connected a load between these two terminals. I think it's about 700 ohms or so, which pulls down that ghost voltage. So that can be a really useful feature, but knowing what we're looking at when we see a non-zero, non-120 volt voltage on our meters and one that changes as we're moving our probe around, that should be a red flag to every technician that what you're seeing is not a real usable voltage, it's a ghost voltage.